So I'm going to draw a circle. It's not a bad circle. I surprise myself every once in a while. All right, so this dot here, I'm going to call O. That's going to be the center. And this dot here is A. And that dot there is B. And I'm going to put C there. So if I draw these lines here, what kind of lines did I just draw on that circle?
Radiuses.
Radiuses or radii.
Yeah. Okay.
What do I know about each one of those lines?
They're the same.
So AO is equal to BO is equal to CO because they're all radiuses. Now what if I call that D? What kind of line is AD?
Circumference.
When you have a line that goes straight across, I'm trying to draw that as one straight line, by the way.
I know, but it's just like the radius twice, but.
Right, that's a diameter. And you're right. So AD would be equal to AO times 2. Right? Because 2 radiuses is equal to a diameter. Okay? So when I'm doing these angles, angle AOB is called a central angle. And that central angle also tells you how much the measure of that arc is. Now the arc length is just a piece of the circumference. Do you remember the equation for circumference?
Is it pi r squared?
That's area.
Oh, okay.
So 2 pi r is circumference, and area is equal to pi r squared. So if I want to find the measure of arc AB, that's going to be the same as the number of degrees of that central angle. So if this is 25 degrees, I'm actually going to make this 30 because I'm going to do something with it later. I want the math to be easy. Then the measure of that arc would be equal to 30 degrees. Those two things are exactly the same as one another. And this is called the measure of an arc. Now, if I want to do the arc length, then I need to figure out what piece of the circumference is in between those 2 points. So I'm going to use the angle to do that. How many degrees inside of a circle?
Inside of a circle.
360. 360. So that central angle and the total amount of degrees is going to help me figure out what piece of that circumference I have. So those two numbers make up a fraction. So what I'm going to do is I'm going to take 30 and I'm going to divide it by 360. That gives me my fraction. And then if this radius is, I don't know, 4, then I can use the circumference equation to figure out how much that arc length would be. So that's going to be 2 pi times the radius, which is 4. So what I'm going to do is I'm going to reduce this. Those two cancel. And then you get 1 over 12 for that part, right?
Mm-hmm.
What's 2 pi times 4? You never use 3.1. You never use 3.14 anymore. You just leave pi the way that it is.
Just be 8 pi.
So it'd just be 8 pi. And so this would be equal to I have 8 there, I have 12 there, I can reduce that again. That goes down to 2, this goes down to 3, and so this would be 2 pi over 3. And that would be what the measure of the arc AB would be. So if I'm looking at this circle, AB is called the minor arc. There's always going to be an arc that's less than 180 and one that's greater than 180. So that would be the minor arc. The major arc would be everything going back to B. So if I wanted to label the major arc, it would be A, D, B. It's 3 letters. I have to put that third letter in order to show which direction I'm walking around the circle. Okay? Both of those arcs are determined by that angle.
Okay.
So the minor arc is the one that's the shortest distance. The major arc is the one that's the larger distance. Is there any other way to label that arc? Is there any other 3-letter combination that I could use to label that arc?
Yes.
Okay, can you tell me what it would be?
Could you do like?
I'm going to start at A.
So A, C, D, no B.
B. That's saying the exact same thing. Because in order to get from C to B, starting at A, I would still have to walk that whole distance, right? So I'm still talking about the exact same distance. So this is the major arc. Again, all this stuff is going to be online, so you can go back and look at it again. So let me do another one. Okay, so tell me this. What does that symbolism mean?
Minor arc.
That means the measure of the arc, which means the degrees.
Oh, so 60.
What if I do that?
Said.
This means the degrees. This means the arc length.
So you don't know that.
Well, we can find it, right?
Mm-hmm.
So let's say this is 3, right? The radius is 3. Then I take the number of degrees that I have there, which is 60. I divide it by what?
3.
What did I do last time? Do you remember what I did last time?
Not really.
Okay. You take the part over the whole, how many degrees are in this circle altogether?
360. Yeah, I remember that now.
And what do I multiply it by in order to find the arc length? What is the arc length part of? Is it part of the area or the circumference?
Circumference.
And what's the equation for circumference?
2 pi. Okay.
Okay? So what is r in this case?
3. Oh, so it's just 6 pi then.
Mm-hmm. What do I do to this? What did I do last time to the 60?
I divided it.
So reduce it for me.
One over 6
Times.
pi r. No, pi. 6 pi.
Now simplify that for me.
Would it just be 6 pi over 6?
Which is, simplify that.
Pi.
It would just be pi. So that's equal to pi. Okay, so find this one for me. That's supposed to be
T
that's supposed to be I. Sorry.
How would you find out what QR is? Or arc?
You don't need it.
You don't need it.
When you're walking that arc length, you walk through those points. So I'm going from here through that point back to there. So how many degrees would that be?
300.
Right. So set up the fraction for me.
Equals 300 over 360.
Times
2 or 6 pi.
You notice that didn't change, right? It's the same circle, so the circumference should be exactly the same. And now reduce that.
5 over 6 times pi, or 6 pi, which equals,
What happens to those two sixes?
they cancel out. So there's 5 pi.
Mm-hmm. Good. All right. That's the last thing I'm going to show you. It's time for me to go. So what you're going to be doing this week is you're going to be identifying major and minor arcs and doing arc length, and you're going to also do sector area. The only thing that's different from this in sector area is that you're going to be multiplying by the area here instead of the circumference, but it's the exact same thing. You use the angles to find out what part of the circle you have, and then you multiply by the area of it.
We won't be doing this until after I see you again, though. We won't start it because, like, Monday and Wednesday, we're taking some pre-SOL thing. Like,
Oh, I thought you guys were actually doing something in class, and then she wasn't just going to do that part. Okay, well, that's fine.
Well, I think she said all we're doing is class. It's just an SOL thing. She might still give us homework, but